Hey everybody, in this video we're gonna learn how to apply Angular in an enterprise setup in the best way possible. Based on my experience as an Angular consultant and trainer for some of the biggest Angular projects, I will show you some key principles to follow to maximize your success with Angular in your enterprise. If you're new to this channel, hey, I'm Christian Luderman, and on this channel I teach you how to become an Angular master. So if that is something you're interested in, go and click that like button for the YouTube algorithm and subscribe to this channel for weekly videos. And if you want to accelerate your Angular career in the fastest way possible, head over to christianluderman.com/Angular Architect Accelerator and get started with the free workshop. Let's jump to the video.
Let's get started here with the key principles of having success with Angular in an enterprise. So we're going to cover monorepos, continuous delivery, feature toggling, high ROI testing, reactive architecture, efficient development process, design systems and UI toolkits, and how to monitoring and optimizing performance. All right, so first and foremost, we have monorepos. So basically, monorepos are when you have a repository which contains multiple projects. That could be multiple apps in the same repository. So that gives the benefits of easy code sharing because code can be shared just by referencing each other in the same repository without needing to create npm packages. And also it gets everything more transparent because you can see what everybody is doing. So if many different teams are working together in a monorepo, it's very transparent what everybody's doing, and it's easy to even collaborate across because everything is visible and accessible. It's going to simplify the infrastructure and the pipeline because you are going to be able to have one infrastructure and run many projects. So you can add more and more projects to the setup without affecting the complexity of the infrastructure. And some tooling I like to use for this is NX, which is tooling for handling monorepo CI, which basically can make sure that when you run tests, linting, end-to-end tests, builds, then you can target just the affected projects instead of building everything every time. So basically, it's gonna be smart and gonna make your builds and all these different jobs you want to run on the pipeline more efficient, as well as supporting module boundaries. So you can control the dependency flow, for example, between feature teams. I got a bunch of different articles that cover this already. If you want to dive into this, you can check out my monorepo blueprint talk. You can check some of my articles where I dive into like the architectural overview of how such an architecture could look like. And yeah, basically I also like to combine this with the concepts of domain-driven architecture. So some of the core principles here are that folders should reflect architecture and not technologies. So that, for example, means you shouldn't have, on the top level of the application have use names such as components, directives, and these like Angular technical terms. Instead, you want to have it reflect the domain. So for example, if you are building a banking application, then you might use top level domain names such as accounts, investments, transactions, and such, rather than, the technical terms. And also you want to split the architecture up in different libraries. So as things scales, it's nice to have, more of like layered architecture, and you can split things up. So for example, you have a layer for your smart components, you have a layer for your data access part with maybe, the store and the HTTP requests and WebSockets and all that. And maybe you have a layer, with interfaces that you reference across and such. And you can use NX tags and module boundaries, ESLint rules to control the dependency flow here. So you make sure you don't have any cyclic dependencies, and you can also control a one-way dependency flow between different layers. Like for example, we know from an onion architecture in traditional, mostly in backend development. So the different library types we're gonna deal with are, on the top level, we're gonna have an app that is able to reference shell libraries. And basically these shell libraries exposes feature libraries from each subdomain referenced by apps, and they are loaded using route lazy loading. So also we have APIs, which is a way to like expose the UI, domain, and utils from a specific subdomain to other domains. We have the feature library type, which contains smart components that is able to access other domains APIs. Then we have the UI libraries, which has the presentational and use case agnostic components. We have the domain libraries, which contains state management, HTTP interfaces, and such that is relevant to the domain. And we got util libraries, which doesn't depend on anybody and is domain agnostic. Helpers, for example, a date helper. So that such a setup can look like this, where we have the app where it's lazy loading these different feature lists, which basically contains the smart components, and usually smart component would be like the page of the Angular component, and then that might contain the domain library that might reference the domain library, which could be like maybe a data access facade, or maybe some NGX, or whatever state management solution is preferred here. And then these more app specific libraries can reference the shared part, which could be like shared functionalities such as the auth. It could be shared UI like design system, or some UI tools. And it could be some shared domains such as shared interfaces, models, shared maybe data access helpers and such. And then maybe shared utils like data util and mutability util. So this is basically the basic setup for like a scalable architecture, because this will scale really well. And if this is more complex, you might even add like the shell library type on top of this that could reference. This could be like a mediator between the app and the feature libraries, but it's kind of optional to add these extra layers. But basically this is something that I've seen scale really nicely, even though it's kind of like a simple to do app in this case, but it'll scale quite nice. And you have like the different segregations of responsibility by having the different library types, which kind of act like layers in the architecture. The next thing is continuous delivery, which is delivering often with small change data, which gives you fewer errors and faster recovery in case of an error, because it's easier to diagnose what goes wrong if it's only like a few lines of code versus like the whole app that's been touched in the change. And delivering often also gives you faster feedback, so which can improve the UX of the app, because you can iterate faster on and create a better product, ideally from the user feedback. And you're gonna see less merge conflict, as branches don't live for a long time if you keep everything released in small changes that maybe only last at maximum 2 days. So it's also called chunk-based development. I got some different articles on this as well. You can go if you want to check out more about how to implement continuous delivery. I've seen it being implemented in even like more like traditional and regulated industries. So that's usually an excuse I heard, that you couldn't do it in this industry, you can do it in finance, you can do it in this, you can. It has been proven in a lot of like surveys that doing it this way with releasing more often in smaller deltas give both more security, and it gives you faster recovery time. So that kind of debunks this process. And you're gonna use something like feature toggling as well if you want to be able to release. You want to be able to deploy without necessarily releasing. So you could, for example, be waiting for the backend to be ready. So that's the next thing, feature toggling. So when doing continuous delivery and trunk-based development, feature toggling is necessary for you can releasing fast. You can deploy without releasing. And it's useful like when you might need to wait for external conditions before you release, for example, backend ready, put a specific date for releasing a new feature. And you can also use this for split testing and beta testing, so you can give certain users access to a new feature. Then you can also read more about like my approach to feature toggling. You can see I have some live Q&A call where I talk about feature toggling, and how to use feature toggling in Angular apps is an article you can go check out, which basically will show you the different ways to use feature toggling and how you can set up with both like the different progressions. Basically it goes from like you have the like poor man's feature toggling, which is like something like you have a JSON file in your app. Maybe you can even like have like a hidden place in the app where you can go and toggle on features in the app. And also you can use a system like Launch Darkly, which can, it's like a GUI system that can provide your dashboard for handling feature toggling. Or you can build this yourself. I've seen all variations. Usually people start with the poor man feature toggling and then they upgrade later with something that can, it's more like a GUI system for handling this. So we got high ROI testing, which stands for return of investment testing. Basically the principle here is to write tests with the focus of getting the highest return of investment. So you want to write not too many tests and mostly integration. It's basically the principle here. You want to focus your testing effort on covering use cases with integration tests, which basically means you're going to run on the whole front end, at least for that part you're testing. And then you're going to stoop out the backend. And I like to use Cypress component tests for that because it's running in a real browser. And it's a easy way to like set up a test just for that specific smart component you want to test. Then we got edge cases and like calculations, which are covered with unit test. I like to use just for that. You got the static testing, you can call it, with ESLint, which is basically running a bunch of rules, and TypeScript as well, by covering a lot of like typing, especially like strict TypeScript rules can cover your application and give you save you in a bunch of like null reference exception cases. And then we got a few end-to-end tests, which I like to do like basic smoke tests. It require a bunch of more setup to really have like use cases running with end-to-end tests, especially when you like want to consider like running end-to-end tests in parallel, and you want to set up like the test user, and you want to make sure the environment is stable to run in. That's a problem I see a lot of the time, that the environment is not stable, so the test would be flaky. So I'd like to start out simple, the smoke test, and basically the heavyweight is covered with integration test with Cypress component test, and then stooped out backend. Because that I find that as the perfect middle ground. And I got a bunch of articles about that as well. About basically, I think the best place to learn about this is either join one of my Angular Architect Accelerate course, where we have like a whole week just covering testing, or one of my live workshops with testing. So you can actually get some feedback as you're building this, as you, for example, introducing tests for your Angular app, and I find it easier to do this with pair programming and in a more collaborative way when you're starting out testing, because it is about habits, and it's about learning the right way to do it to make it efficient. Otherwise, it's not really it's not really gonna be applicable if you spend a lot of time writing tests. You need to be efficient with it. And then we got reactive architecture, which keeps data in the observable stream until it needs to be used for presentational usage, which could be HTML, or communication, which could be like you unwrap the value from the stream, for example, when you need to be passed to an HTTP request. I like to use facades for new projects to like abstract the whole data access layer, and not get hard coupled to any third-party state solution. And then you can later decide if you want to use NGX or some other state management solution. And I like to emit actions as events, so you make the event usage agnostic, so you don't need to like hard couple the event from like where it's actually being handled, because it could be handled by another feature team, for example, and then you don't want to have that especially implicit. You don't want to have that specified necessarily. So you keep it more flexible. And then smart and dumb components. So the basic flow is you gotta have some state from the state layer. It could either be like from a HTTP request, or it could be something that's already cached in the store. And if from the observable, you get it through the facade down to the container or smart component, and then down to the presentation component. When something happens, let's say you click on a button, the event will go up again, boom, to the facade. and then something happened updating the state. Maybe it's gonna fire an HTTP request and update some state on the server. So that's a basic flow, up and down. And you want to keep the data in the stream, not convert it to a promise. Don't subscribe early and map it to a state field. You want to keep the value in the observable until it's actually used. So it's also something I have been covering here in a blog post, how to refactor your Angular apps to a reactive architecture and what the difference is between the imperative way and the reactive way of building Angular apps. This can be a very big change for a lot of people. So you might also consider joining a workshop or get some kind of sparring for how to introduce this for your specific cases, because this is going to solve race condition and a lot of problems you're going to have if you don't know how to set this up with a reactive architecture. Then they have an efficient development process, and that's both in terms of continuous improvement and development. My basic recommended development process for most teams is for the refinement process, you pick a chapter lead, or you can pick multiple chapter leads to refine a story. They're gonna refine the story, they're gonna create all the subtasks for the story and kind of make a draft for the story. Then you have a story kickoff, as for example, normally as the sprint starts, where you present that to the team, how you see the story is best implemented. And then you can make necessary adjustments. And once you are agreeing on that, it's kind of like doing a huddle in American football. And then you kind of agree on that, and then you're ready to play. And then I recommend starting with pair programming as you build the skeleton of the story, where, for example, you might agree on like naming conventions and create the components and create the state structure and all this. So it gets easier to split up later on when you can split this up in multiple different tasks, and you can work in files that are already created from step 3. So also I see when you do the pair programming and you do like more a collaborative way early on, then you're gonna have less confusion and less regression later on, because you already had that higher bandwidth of communication early on and to discuss naming and like how everything should be set up for a certain story, which is nice. And then you also want in your team to be able to like continuously improve your infrastructure, and you basically introduce new ideas and optimization ideas. So you should be able to propose different things you can decide on. So I like to follow this 4-step process for introducing like having continuous improvement. So step 1 is propose a decision. So you want to have some decision. Could be like, should we use NGX or should we use this state management solution? So you're going to have a background. You're going to have consider different implementation options. Then you're going to put it on a log on an agenda for these meetings. So there's going to be a bunch of decisions to be made, and everybody can do it. Not only the tech lead or whatever. Everybody should be able to collaborate with like suggestions of improvements. Step 3 is you have this weekly or bi-weekly maybe front-end chapter meeting where you go and and you go and discuss these different decision log items that's been added, and you go and basically look at the different solutions and which makes most sense, and you maybe do a vote on which one makes most sense, and you decide on a decision, and you lock the decision so you can trace and you can see later on in an audit like why you made that decision, and then you settle on the decision, and then you end up putting it on as a task on the board, so to be implemented sometime. So I like to do this process. So it's like a democratic way where everybody kind of have a voice to create improvements in collaboration. And because without having this system in place, it's kind of like whoever is in a position of like authority, like you might be the tech leader, you might have a job position, or you might just be like the most outgoing and might just be the loudest person in the room. But basically you want like everybody to have like an easy way to be heard. And I think having a system for this makes sense. Otherwise it's going to be like more like whoever has the biggest mouth is going to control this. And then basically this process is also covered in a blog post where I have some post about the process efficient sprints. You can see me talk about that when at the point where I had a very nice haircut during COVID. And I talk about projects and lessons learned, and yeah, basically also this some pull request approach and more to like development approach and productivity posts you can take out. Then we got the design system and UI toolkits. So basically these are tools that gonna give you make development easier and more consistent. You're gonna have a bunch of building blocks then make development easier. The easiest way to start creating a design system, at least the documentation for it, is using a storybook, because it's gonna be an easy way to like showcase the different UI components in your design system. And it's ideal to like base it on something like Angular material or some other solution for handling the UI. And basically, you want to have it like branded for your organization and all that. So it looks consistent and nice in all your apps. And then I also like to use UI toolkits like Tailwind CSS to minimize the amount of CSS to write and instead reuse a lot of the CSS classes instead. So basically, Tailwind CSS allows you to I can just go to the website Tailwind CSS. Basically, this tool that allows you to build and style websites without leaving your HTML. So you just add these classes, and it has these like design token values here. Instead of having pixel values here, you're gonna have some abstracted values that gonna reference design tokens, which is ideal for keeping things abstract, and you can change stuff later on without updating all the usages. Also, you can do it for responsiveness, like you can do a medium device screen here and apply some styling for that. Basically, this is the fastest way I've seen to style Angular apps and any app in general. And it's getting more and more popular. People are going away from the semantic way of using CSS, where you have the classes, for example, there's some usage name like submit button or something like that, and then you write the styling. This is a lot faster, and even though you're gonna duplicate some of the classes, some of the CSS classes, I think it's gonna be a big win, because then you're gonna write less code. You're gonna have the design tokens in place with these different values, and you're gonna have media queries covered here, and you're gonna have like color values and all these other design tokens. It's just way faster, and I think that is the most important thing. Way to have it as fast as possible, and you can still move components into Angular components, and then you reuse that. So I definitely think it's the fastest way, and I see more and more people starting to use Tailwind CSS once they initially once they start to accept that they're not going to be writing CSS anymore, or at least not as much, and they can accept the maybe loss of like segregation of responsibility, that you're not keeping the styling in CSS. But I think this is a fair way to do it. I think it definitely makes sense, and you can at least cover like 90% of your styling needs just with Tailwind with these classes here. And it's even like tree segregable. You're only gonna have the styling generated that is represented in the HTML here. And I also have a post about that where I talk about how to structure styling in Angular app, and basically I say you should have a grid layout in place, which you will get from kind of CSS grid and Tailwind CSS. There's some helpers for CSS grid. Position helpers you're also gonna get from Tailwind CSS, and then you can at least sometimes you need to actually write CSS still. So you will then write the last maybe 10% with CSS, but this is the fastest way to do it, definitely, and it's getting more and more popular to use Tailwind CSS, so I definitely recommend checking that out at least, and see if that also makes sense for you. And then we have monitor and optimize performance. You can start by setting bundle budgets to make sure like your bundle size not getting too big. Of course, use best practice techniques like lazy load the different feature modules. Make sure like one bundle doesn't get too big, otherwise that's gonna kill your load time performance. You can use Webpack Bundle Analyzer to analyze, maybe you have a big third-party library and maybe some big stuff dragged into the app that's going to make it bundle too big. You can see that with Webpack Bundle Analyzer. And the low-hanging fruits, such as unpushed intersection, put smarter DOM components, puts reactive architecture, basically makes the runtime as efficient as possible, because you're gonna have the most efficient change detection. Also, you can do optimizations, such as I did a podcast not so long ago with Mikael Lotke, where we talked about RX Angular. So basically, RX Angular is this project here where you had the push pipe and the lead pipe, which can basically is the most efficient way to do change detection of a certain for a certain element. And also it can run zoneless, so that's another optimization you can do if you really need to. But it's currently there might be some complexity in an enterprise setup when running zoneless. But yeah, if you want to learn more about performance, I recommend you check out my performance articles. Definitely this one is the most current one, and there's a lot of good content in this podcast here. But you can also read like some of the other that cover how to optimize your Angular performance.
If you like this video, make sure to give it a like and subscribe for more videos like this. And if you want to accelerate your Angular career in the fastest way possible, head over to christianludemann.com/Angular Architect Accelerator and get started with the free workshop. See you next time.